How GPS spends time to find you. This is the strange story of how the little blue dot on your phone depends on Einstein's theories of relativity. To know where you are, the system has to account for the fact that time itself runs at different speeds in space and on the ground. Let's start with the basics. GPS, the Global Positioning System, is a fleet of about 30 satellites orbiting roughly 20,000 kilometers above the Earth. They were built by the United States military, but today they guide everyone from delivery drivers to hikers to the Maps app in your pocket. Each satellite does something deceptively simple. It constantly broadcasts a radio message that says, in effect, this is where I am, and this is the exact time I'm sending this. That message travels down to Earth at the speed of light. Your phone listens for these messages from several satellites at once. By comparing the time a signal was sent with the time it arrived, your phone calculates how far away each satellite is. Distance equals speed multiplied by travel time, and the speed here is the speed of light. Now, imagine you know your exact distance from one satellite. You could be anywhere on a giant sphere around it. Add a second satellite, and the two spheres overlap in a circle. Add a third and a fourth, and those overlaps shrink down to a single point. That point is you. This method is called trilateration, and it lives or dies on the accuracy of time. Because the signal moves at the speed of light, a timing error of just 1/millionth of a second translates into a position error of about 300 meters. That is the length of 3 football fields. So the entire system is really a clock problem. Every satellite carries an atomic clock, a device so precise it would lose only about 1 second over millions of years. The whole point is to keep time so perfectly that distances can be measured by light's travel. And here is where the universe throws in a twist. Time is not the steady, universal thing we imagine. According to Albert Einstein, the rate at which time passes actually depends on how fast you move and how strong gravity is around you. The satellites feel both effects. The first effect comes from special relativity. Einstein showed that a clock that is moving fast ticks more slowly than a clock standing still. The GPS satellites race around the Earth at roughly 14,000 kilometers per hour. So from our point of view, their clocks run a little slow. How much slower? Because of their speed alone, each satellite clock falls behind by about 7/millionths of a second every single day. On its own, that tiny lag would be enough to ruin the system within hours. But there is a second effect, and it pushes the other way. This one comes from general relativity, Einstein's theory of gravity. He realized that gravity also slows down time. The stronger the gravity you sit in, the more slowly your clock ticks. Down on the surface, we are deep inside the Earth's gravity. The satellites, far out in orbit, feel much weaker gravity, so their clocks actually tick faster than ours. This speed up amounts to about 45 millionths of a second gained per day. Now we add the two effects together. Speed makes the satellite clocks lose 7 microseconds a day. Weaker gravity makes them gain 45 microseconds a day. The net result is that each satellite clock runs fast by about 38 millionths of a second every day. 38 microseconds sounds like nothing, but remember the rule. Each microsecond of timing error becomes about 300 meters of position error. Left uncorrected, your GPS location would drift by roughly 10 kilometers every single day. Think about what that means. Within a couple of minutes, your navigation would be off by a city block. Within a day, it would place you in the wrong town entirely. A system designed to find you two within a few meters would become completely useless almost immediately. So the engineers did something remarkable. Before the satellites ever launched, they deliberately adjusted the atomic clocks to tick at a slightly slower rate than normal. Once in orbit, with relativity speeding them up, they settle into exactly the right pace as seen from the ground. On top of that, ground stations around the world constantly monitor each satellite and send up tiny corrections. The math of relativity is not a footnote in the GPS design. It is woven into the core of how the system keeps time and keeps you on the map. So the next time your phone quietly shows you exactly where you are, remember what is happening above you. 30 satellites are racing through space, their clocks bent by motion and gravity, all corrected with Einstein's equations. The blue dot on your screen is proof, every single day, that time really does bend. And we have learned to bend it right back.